Is that a question, or?
Is there a single problem usually with the anterior cingulate in one frequency, or is it sometimes a couple frequencies?
Yeah. In fact, I've simplified it into 3 clusters, and you can have a bit of a mixed pattern, but usually they show up as one or the other of those 3. Yeah, you'll find a predominant one, and that predicts what medication class you might try. By the way, I wrote this retrospective paper in 2005 on EEG phenotypes, and it scared the hell out of me to publish it because it's, I look backwards in time at 500,000 EEGs, and when you see this pattern, they respond to these drugs and these neurofeedback protocols. But it's retrospective. It's like driving your car looking at the rearview mirror. I mean, you can drive off a cliff if you just look out the rearview mirror. I was afraid that people would take this retrospective, non-validated model and use it as though it was validated. And it scared me, but I published it anyway because how do you test a theory? Well, you publish it and then people can test it. And you have to publish in peer review and then have it tested. So I put it out there, and luckily I didn't see anybody drive off a cliff based on it. And the validation studies have actually validated most of the model at this point, over a decade later. Including, initially, there were only 2 of the 11 patterns I identified that had known genetic correlates. And at this point, they've identified the rest of them. I can't the genetics because Johnson & Johnson hired us to, we did the phenotyping on 100 patients, and they did the genotyping, full genome workup, about $4,000 a patient at that time on 100 patients. Do the math. They dropped $4 million on this crazy project. And their statisticians basically thought it was a waste of their money, and they waste a lot of money all the time anyway. They're drug companies. They have a lot of money to waste because they charge us excessively for our drugs. They found that it clustered the genetics based on the EEG in a way that they didn't expect, and they found correlates, but it's their data, and under the contract I can't talk about their data, but Martijn Arns and I did the work, and he did some swab DNA, and we can report that, and we actually found COMT genetic correlates with the beta spindling. So the genetic correlates are out there, but they consider that their market edge at this point. And I couldn't even say it was Johnson & Johnson until they outed themselves at an IPEG meeting in New York. That they admitted that they had done this, but it's their data, and I would love to tell you all about it, but the contracts are really brutal. And if you want to be drawn and quartered, go ahead and violate your drug company contract. So I'll just let you know that the phenotype model, all of the clusters have been genetically correlated at this point, and there's strong genetic correlates. If you have questions or comments, or you want to throw things at me or something, feel free. This is your moment. One here and then in the back.
The anterior cingulate, it's actually down. So projection of the EEG may not necessarily be straight up, and that has implications for how we train.
Yeah, in fact, if you look at it, the cingulate's essentially on the side, down inside the fissure, and the right cingulate projects up to the left, and you quite often see it at the midline and to the left. And you see something left frontal, and you think, oh, it's something left frontal. But if it's right cingulate, it projects up to the left. If it's left cingulate, it projects to the midline and to the right. When you combine them, they're solidly at the midline. It's general that you see both hemispheres with a cingulate problem, but you can have unilateral. I've seen both. It's more common to see both of them fail than to see only one of the sides fail. But again, you get a simple model and you know it can't be true. So.
Loretta is not good enough to make a distinction for small changes in the cingulate. We looked at that, and the correlation coefficient between left and right was like 99 points, which means that it's difficult with Loretta to say, is it purely left or is it purely right? And from a functional point of view, if you do unilateral cingulotomies or unilateral implants in the cingulate, after a week, it doesn't work anymore. Mm-hmm. So the targeting should be bilateral, even if you only see unilateral.
And we had another question back here.
Jay, I was just wondering about, with the OCD sort of focus and the meta-analysis that you've done, what about eating disorders in terms of anorexia, which is impaired cognitive function is absolutely there? I'm just wondering what your pattern found there, if anything. I don't really know what you're looking
Well, we're currently doing an EEG study for anorexia, and the thing, as Jay said, there's actually also subgroups in anorexia.
Yes.
We do it in New Zealand, where the population is not that large, so it takes a long time.
Sure.
I don't know, I'm not aware, I haven't looked at the literature on other patterns of anorexia, so I can't really give you a good answer right now.
Sure, okay. All right, look forward to
In clinical clustering, we've seen anterior cingulate in eating disorders in general. Anorexia, bulimia, they're related to an OCD drive, and you kind of assume it's the same underlying substrate, and that's what we're seeing. Now, again, the real neuroscientists will do the real neuroscience, and I'm happy to be wrong, but at least I'll let you know my theory, and at that point it's testable. So.
There's a new amplifier coming out that uses Laplacian coils to record sites. So their selling point is that they can reach up into high gamma instead of the muscle noise. Are you aware of this system?
They're actually, if you use a coil to detect content that's essentially the MEG, SQUID, the quantum interference device is a coil immersed in liquid helium, and it detects radial current source density. And it's like a Laplacian montage looking at EEG, only it's looking at MEG. But they also see much deeper than we do. They can see subcortical sources that are monopoles that we can never see with EEG. So the MEG is a wonderful tool. Dry sensor technology in EEG is something a lot of people are trying to do, but to look at the data on a dry sensor and a real wet sensor pasted on disk, and below 3 hertz dry sensors are not reliable. They have contact jitter, and as such, although the amplifier associated with the dry sensors are great, the contact is the issue. If it's a metal contact, it's worse. If it's a polymerized, it's actually a damp sensor because the polymer holds a little moisture. It'll absorb moisture from the skin, and you get almost a salt bridge, but not quite. So there's improvements that have been done. But there are groups in Europe working on room temperature, coil, inductively coupled, and at that point you won't need contact. In fact, if you had contact, it would goof up your signal, so that it's insulated, so you can't actually touch it to get real contact, but it will pick up radial current source. They have it working in liquid nitrogen, which is a lot cheaper than liquid helium, but they haven't quite got it at room temperature. This is probably solved by material science at some point. I'm looking forward to it because I've been in EEG forever. When I started, we used needle electrodes, 21 needle electrodes stuck into a kid's head, and then tell them to relax. How many ADD children can you do in a day? Well, can you chase them down? You come into the room with these 1 centimeter needles, and I'm gonna stick 21 of these needles in your head. I'm out of here. So traditionally, we would knock them out with drugs and then record their EEG as though that was a valid EEG, Demerol, Phenergan, and Thorazine, a DPT cocktail, and a little syrup and down the hatch, and pretty soon they're out. And then you can stick the needles in them and record them. But then I used 2 amplifiers, too. Grass Model 1 was the first instrument I used. 1,500 watts of tube power, and you'd have to turn them on an hour and a half or so before you wanted to use them because they weren't temperature stable. So technology has advanced a lot, And I'm really happy to see that. And if they get to dry sensor technology that works, I'll be happy to adopt that. Right now, I'm still a bit of a skeptic about dry sensor technology replacing pasted on disk for EEG, QEEG for clinical work. If you're playing around with your own EEG and you're doing feedback and you want a dry sensor technology and you're not looking below 3 hertz, it's probably reasonable. Most of them don't give you an actual EEG signal out. They take a number of epochs and smooth them together. So if there's contact jitter on 1 or 2 of the epochs out of 8, it kind of averages that jitter out, and it gives you a smoother signal. But smoothing the EEG across 8 2-second epochs isn't my idea of a raw signal. So it doesn't really give you the kind of data that you want for clinical work. So they're close, but not quite right now, and they'll get there. It's just not quite there yet. We're going to be discussing sex differences, and last I knew, people could kind of tell the difference between males and females. So why do we combine males and females together in the same database? A normative database that we're going to compare people to, and it combines males and females, which you can see the difference physically, not just the outside, but if you look at the brain physically, it's a different structure. In general, males have a larger left hemisphere, so they all puff up proud, we have a big left hemisphere, but females have a massive, well-developed corpus callosum. We should have callosal envy, for God's sakes, The connectivity between hemispheres is dramatically different. Why would we think that the brain's electrical patterns are identical between males and females? Well, in fact, I kind of know that they're not the same. But, if you're collecting a database, you'd have to collect 2 databases. If it costs you over $1 million to collect a database of 500 to 700 people, and you're going to have to double that expense, you're going to have to make your money back selling it somehow. And they basically say, well, they're generally the same, so we're going to combine them. And you can plug your nose and do that if you want. But if you think about it, young kids develop at a different stage. Males and females are out of phase in their developmental trajectory. If you combine 2 lines that are out of phase, what do you get? Something you don't want to be compared to. And unfortunately, we've had to plug our nose and use the databases we have because that's the only databases we've had. But about 6 years ago, a group in South Korea was at a meeting, and they indicated that they got a government grant for 5 years to start collecting a Korean normative database. But Doctors Kim and Kang from National University in Seoul, MD PhDs, wonderful gentlemen, asked my advice. And I told them, well, you can do it like everybody else has done, combining males and females and giving the means and standard deviations of univariate measures in the brain. But the brain's not a univariate processor. And patterns can be highly abnormal when every single measurement in the pattern is within a normal limit, but the pattern itself is abnormal. Multivariate analysis. If my right hemisphere is 1 z-score high, that's within normal limits. The left hemisphere is 1 z-score low. That's within normal limits. That pattern is not normal. So don't do what everybody else has done, or we'll just have another widget that's like everybody else's widget. Why would you do that? Keep males and females separate, because I can tell the difference, and the brains are structurally different, and I would guess that their patterns, the functional patterns, are going to be different, not combined. And until we separate them and have a large enough number of people to judge the norms, we won't know. So I'm assigning you twice as much work if you listen to me. But you don't have to listen to me. You talk to anybody you wish, do the database any way you wish. They said, well, we'd like to hire you. And I said, well, no. I'll advise you for free, because if you pay me, it's going to skew my judgment. And I want to give you a clear judgment. Right or wrong, it'll be my opinion without any financial bias. So they liked that answer. I mean, it would save them some money, but we became fairly good friends over the 5-year period. And they've collected, at this point, 1,280 normative individuals. Most of the databases that are out there are 700 or so. So they're doing the heavy lifting. They have more kids, 6 to 18, than adults, because there's a lot more change during that rapid development. And they go only up into the low 80s for age. They don't go into, 90-year-old or anything like that. But, there are not too many clients getting QEGs at 90 years old anyway. So the norms at 82 or so will probably suffice. iMedicine, email, Sungwan Kang, MD, PhD. There's his email address. And he gave me permission to show this. They're releasing their database in October. And I don't have any fiscal interest in it at all, which means I don't have a conflict of interest to tell you about it. They've done the heavy lifting of keeping males and females separate. So at this point, we can actually look at the difference. Now, we're not going to tease apart the entire database here for you, but I'm going to show you some Loretta images that show males and females separately for broadband analysis, which is a terrible way to analyze the EEG, delta, theta, alpha, beta, gamma, but as a demo of difference, it's an easy demo to set up and structure. You could do it in 1 Hertz bins if you'd like, but this is a way to demo it, not that this would be the way they finally analyze. And after the 5th year of acquiring data, Dr. Kang got a 1-year sabbatical, and he said, now that we're collecting the data, how are we going to analyze it? How are we going to present it? And I said, well, if you've got a year off, I need to introduce you to the Schwartz Neurocomputational Group in San Diego. And they do very high-level analysis. They're neuroinformatics, people that do mathematics for neurophysiology. And they're brilliant, and they do wonderful analysis, and their software is shareware. They don't sell you their software. They give it to you. But the EEG lab software is what most major academic labs are using for analysis. And it's shareware, because they're academic neuroscientists, not venture capitalists or vendors. And as such, they give away their product, which I really like. Science shouldn't cost you an arm and a leg. It should be something that we can share. So they spent a year going over the highest level of mathematical analysis the EEG can have. Now, in our field, this is very controversial. There are vendors who sell software that their approach will not work with these approaches because their database wasn't processed with these approaches. So step 1 is to de-artifact the data, and they de-artifacted their data with independent component analysis. And there are a lot of people that will immediately throw up their hands and go, oh my God, that ruins the EEG. I've heard that it ruins the EEG. Well, that's an interesting theory. Let's look at it in practice. Now, if you do a traditional de-artifacting, you cut out segments of the EEG and you splice the ends together. The Gavitsky-Soleil, there's fancy knitting programs to make the waveforms match up, but they actually distort the EEG a little bit. Now, not badly. These are the best tools we have, but the more times you cut pieces out, the more distortion you add in. So rather than cut out the big eye blinks, which everyone can see, we extract the eye movement component with independent component analysis, which almost all of neuroscience has agreed is a purely good way to treat the EEG. If you look at the published literature, it's ubiquitous. Independent component analysis or other source extraction techniques are used to clean up the EEG. And those who rely on cutting out of epochs will say, well, when you do it that way, it changes the result from what we do when we cut out the big eye blinks. And I have to agree. So change isn't necessarily damage. You have to look to see whether it's a correction or whether you're actually damaging the signal. If you cut out all the big eye blinks, the result is going to be different than the ICA because there are small eye movements left in. Not that you did a bad job. No, it's not that you were shoddy with your work. You've done the best work you can cutting out the ones you can see. But you know, saccadic eye movements are small eye movements. And they happen in the 80 millisecond range, which is like a alpha wave-ish frequency. And they always happen. Either you're looking at something that's moving or you're moving your eyes. Because if you hold your eyes perfectly still, your rods and cones habituate to the input. You wouldn't see anything unless you moved your eyes or looked at things that were moving. So we're not all doing this to keep seeing things. Our eyes twitch. And it's not like you're deliberately twitching your eyes. When you tell somebody to hold their eyes still, if they're not blinking their eyes and they're not moving their eyes sideways, the assumption is that's clean EEG. It's not. It's full of small saccadic eye movements. Now, if we've had to do the old techniques and this is the best we could do, you live with that because it's the best you can do. You can't do better than you can do. It's the best you can do. But now that they have the new techniques, you can do better. And if you take out the vertical and lateral eye movement components, you actually clean up the big eye movements really well, but you also take out all the small saccadic eye movements. So it will change the result, but it's a super clean EEG, not a traditionally clean EEG. And those that sell you software that can only do the old approach will say that that damages the EEG. The question is, can I take the ICA and apply it to the cleaned up EEG where you've cut out the epochs and take out the residual eye movements that you didn't cut out? And is that result the same as the ICA cleanup in the first place? And they're almost identical. The difference is that you've cut out a whole bunch of the EEG. So instead of 10 minutes of cleaned up EEG, you'll get 6 because you threw away a bunch of it. And if I then extract all the ICA and limit it to the epochs that you've left in, we have the same answer. Exactly the same answer. And I've demonstrated this a number of times. And for those who are open to looking at it, it's a very convincing proof. You get the same answer, not a distortion. But if you're not open to looking at it, you'll say it's changed. And you know, this is not a proper handling of the EEG. What do you do in this field when you have an argument? You know, we argue. Yes, it is. No, it isn't. Yes, it is. No, it isn't. Yes, it is. No, it. I had 4 younger sisters. They argued that way, you know? And this is an authoritative argument. There's no answer. You agree with one or the other, but there's no answer. It's 2 people arguing. Our field doesn't need arguments. It needs peer review and publication. The jury of our peers settles arguments. Mathematical proofs settle arguments. But arguing is fruitless. So I've given up arguing. I simply allow mathematical folks to do mathematical proofs. And those that are open to considering the newer approaches can use the newer approaches. But the jury of our peers has spoken. ICA is ubiquitous. You know, one of the big names in the field that disagrees with the ICA use ends up being rather adamant that it damages the EEG. And he posted a paper on his website and said, you know, this is a phase reset paper. And if you did ICA cleanup on this, there would be no phase reset literature because ICA randomizes phase. It does not. It does not randomize phase, but that was the argument. And I simply flipped to page 6 in the publication under methodology, where it said they used ICA to clean it up. And immediately the paper was withdrawn from the site. The jury of our peers basically is neuroscientists that have looked at this and have agreed that it's perfectly acceptable. That paper was from Richard Davidson's lab. He's the one who did Dalai Lama's monks and the gamma and all of that. Rather than argue, I suggest that look to the peer review and publications, not to opinions. Opinions are like my younger sisters arguing, and it's a fruitless argument. You'll never settle it. So these neuroscientists listen to me, but trust but verify sort of a thing, and they went to Schwartz Neurocomputational and spent a year going over these techniques, and they're using the ICA cleanup for eye movement as they de-artifact the EEG. Let's go to the next slide here. Here we have the construction of the database. Informed consent, self-report, to check on emotions and lifestyle. So this is a little bit of a neurocognitive self-report. They then acquire the EEG and event-related potentials because they do a 21-minute ERP recording as well. So they have ERP norms, not just EEG norms. They also have genetics, diet, lifestyle. I mean, it's a normative database, not just EEG. They have a computerized neurocognitive test. If they get through all of this, they do a neurocognitive test as well. They basically have a standardized data processing. They basically do a neurocognitive test of 5 domains, and if you pass that, they test for depression, state trait anxiety as a test. If you pass all of these, then they would get you up to the further levels. They have 1,280 totally collected. Of that, they have 1,059 of them working in the database. They're adding the rest of these. So there's this is acquired and included in the database as 2 separate numbers. Again, a large number of children and a fairly good number of adults as well. They end up with 4 minutes of eyes closed EEG, 4 minutes of eyes open, and a 21-minute visual CPT task. It's like an IVA or a TOVA test, but you record the EEG at the same time. And their frequency band goes from DC to 150 hertz. A little different. Gamma 2 norms, Ripple norms, not stopping at 30. Roy John stopped at 25. The same amplifier was used in the NeuroGuide database up to 30. But the Russian database goes to 45. The Australian Brain Resource Company goes to 42. But they all basically stop before they get into the 50 or 60 hertz range, where you have to have a notch filter to take out the main power supply frequencies. But they go all the way up to 150 hertz. So this is really quite an advance above and beyond just looking at sex differences.